Part 8, Resolution and Web Player Setup. Alright, we still have the default blue background, and we should really set it to a black background. Fully 0, 0, 0. All channels 0. While we do this, we should set the default brush color to white. Save the scene. Also in the build settings, we should add the default scene. Add current. And then at this point we can click build and build a web player. Although we still have painting logic to add. Save the project, save the scene. Okay, now it's time to add some update logic, but we're going to need some helper functions. These helper functions are for the opacity changes. Rather than just apply the color from the alpha mask, we want to stay within the limit of the opacity change. This is for brush strokes. If a brush stroke curves around on itself, you don't want to exceed the opacity change. So we keep it within its limit and also the limit of the field. We don't want to exceed the bounds of 0 to 1 for the alpha channel, as well as a difference of more than the opacity change for any channel. We'll add a couple methods for painting and erasing that stays within the confines of the opacity. When we paint, we take a snapshot of the current pixel value, and this will keep it in range of that original pixel value, plus or minus the opacity ratio. Simple min and max calculations here. We need one more helper method. So not only do we have the opacity change to watch out for, we also want to influence the brush overlay color on where we're painting. So this will select the closer value. If we've reached the opacity change, we'll select that. Or if the destination value is closer to our brush color, we'll select that one, whichever is closer to what we want. And actually, we always want to grab the closer value to our destination brush color, but it has to stay within range of the opacity change. Otherwise, we've painted or erased too much. Alright, now for the bulk of the painting logic in the update method. We've already added code to move the brush overlay, and we need a declaration for the canvas texture, because that'll be accessed a few times depending on whatever condition we're doing. We'll need some error checking. Now, if the Unity GUI has intercepted our click, we don't want to paint. so we can abort out of that. And we don't want to constantly apply texture updates. So we need a delay, and that delay works by a simple timer, as well as a flag we set if we've detected a change. When we want to apply the update, we get the canvas texture, do an error check, and then apply the update. Our timer will update every 100 milliseconds. Somewhere between 30 to 100 is good here. The more often, the slower the performance. Okay, also we want a way to undo. Now this is one level of undo. If they right click, we want to get the canvas texture and apply the last time we took a pixel snapshot, and then it'll just revert that change. If we want to do more than one level of undo, we just save more snapshots. And you can do that more efficiently than saving all the pixels. We could just save just the changed ones or whatever. And when we set the snapshot, just set the detected change flag, and the next texture apply delay will pick that up and apply the change. Alright, here's the left mouse button. We want to detect strokes, so as they click and drag, we want to be able to detect whether they first clicked or they've been clicking. We do this by saving the button state, and then we just compare with the last one. If they weren't pressing before, this is the first time they pressed, or if they were pressing before, it's just part of the brush stroke. And then if they're not pressing at all, we have nothing to do, and we just return. In the case this is the first time they're clicking. This is logic to detect that. After we've detected whether they're just clicking or they've been clicking, just record that button state. And now we're on to really applying the brush stroke. So we're going to need the brush texture so that we can use the alpha brush. Don't forget some error checking. We also need the canvas texture so we can paint on it. Alright, if this is the first time they've clicked and they weren't clicking before, copy the pixels. We'll use this in our opacity calculation as well as the undo operation. Some error checking. We need to make sure that we have access to the brush overlay so we can get the position. Now, our UI has a brush opacity slider that uses values 0 to 100. We need to normalize it to the 0 to 1 range. We also use the brush slider. And we're going to use that brush size to calculate where on the canvas to paint. Alright, this is where we calculate our target window. Where on the canvas to paint. We also want to alter the scale because the canvas texture is a power of 2, a 1K texture, 1024 by 1024, and our canvas is smaller, 1024 by 768. So we need to normalize it and then scale it back to the canvas size. So that'll stretch our window to the appropriate size. We'll be doing the same thing to the alpha brush. Take those original pixels and stretch them to apply to the canvas based on the brush size. In the end, it should be painting exactly where our brush overlay is, in the same exact shape as the alpha brush. We have some bounds checking. Also calculate the size of the where to paint. That target window, some air checking to skip if we're not actually in that, if we have an invalid size. Now we've got to iterate over our canvas area we're going to paint on. We want to get the destination pixel color as well as our source alpha brush color, and then apply our calculations. So we need to find out the x and y of the source pixel and the destination x, y before to paint. Scale everything. And we paint the red, green, and blue channels. The alpha channel, we just use the opacity slider. Red, green, and blue channels when we're painting. We apply our opacity logic, as well as we try and get it to match the same color as our brush color. If we're erasing, it's just a straight erase. It ignores the destination color, or the brush overlay color. After the pixel color is calculated, we set the pixel, and then we throw down the detected change flag. That'll get the texture apply to pick up our change in the next delay. Now we can test out our changes. Here we didn't set the default color in the scene to white, so black on black, it's hard to see. Right, the opacity is set to 100%, just a straight paint, but if we lower the opacity, we can see the brush strokes and that opacity logic. We can also set the color, and it'll try and paint towards our desired brush color. Here I'm doing circles over the same place, and it's not exceeding the opacity of the original color until I click again. I can loop around, and it didn't exceed. I can draw over orange a few times, and it doesn't exceed the opacity that was calculated when I first clicked on the brush stroke. Try some different brushes. More experimentation. Here I'm testing out drawing and erasing and painting black over. So there's painting black and there's also erasing, slightly different. Next, the conclusion of Series 1.